4, measuring enthalpy changes. So this deals with experimental reactions to find the enthalpy of that reaction. Previous section we talked about calculating it with simple enthalpy of combustion reactions. This deals with actually experimentally calculating the enthalpy changes. And how to do that is with a calorimetry, or calorimeter. The science is called calorimetry. Basically, it's a poor man's calorimeter is a coffee cup or a styrofoam cup, lid and thermometer. It's insulated, not the best insulation, but it gets the job done for a quick experiment. What we need to use to find the enthalpy, which is the heat, which is Q, is the equation is called MCAT. The M is for mass, in grams. The C is a constant for whatever liquid we're dealing with. Generally it's water, so CP is generally 4.18 joules per gram Celsius, called specific heat constant. And delta T is the change in temperature, so what it started at and what it finished at. For most solutions you can substitute grams and milliliters because most of the time we're dealing with water. And we remember the density of water is 1 centimeter cubed is equal to 1 gram. So I want you to practice these problems. They're pretty simple using MCAT. Calculate the energy when transfer temperature of 75 centimeter cube of water rises from 23 to 54 degrees Celsius. Remember, MCAT is mass, so you're going to use the density to convert 75 centimeters cubed to grams. CP is 4.18, and then the delta T is the change in temperature. And in part B, you have 8 grams of salt dissolved in 4 milliliters of water. Temperature falls, so it's endothermic, from 22 to 20.5 degrees Celsius. Calculate the energy absorbed by the solution. The 8 grams of sodium chloride is not involved in the calculation. The 8 grams involves in the temperature change. That's why if you had more grams, you'll have more temperature change. You just use the 40 milliliters of water to grams, and that would be your mass for MCAT. And number question C, you have 50 milliliters of NaOH to 50 milliliters of HCl, which makes a neutralization reaction, which is exothermic, and it starts at 18 degrees to 33 degrees. Assuming that you're dealing with small concentrations, and when you make NaOH and HCl when you add NaOH to HCl, you get water. So you actually add the 50 milliliters of both to get 100 milliliters, which would be 100 grams, and then you have the temperature change and MCAT, or specific heat, to find the Q for MCAT. So here's an example of a neutralization reaction just like the problem we just showed. So we have 50 milliliters of 1 molar HCl, and you add 50 milliliters of 1 molar NaOH in a styrofoam cup. Basically what's going to happen is you have a energy increase to release energy per mole. Another experiment is dissolving. You have a styrofoam cup, water, and a solid, in this case NaOH, and when you mix NaOH and water you get an exothermic reaction, increasing the thermometer, or increasing the temperature, so you get the temperature change, and you would get the enthalpy of reaction based on the temperature change, the amount of water, and specific heat of water, which is 4.18. So here's an example. We have the mass of empty styrofoam cup at 23 grams. Add water, which is green. Reweigh it, you get 123.45 grams. So that means the mass of water is 100.45 grams. Initial temperature is 18 degrees. You add NaOH pellets, and it doesn't matter really how much, based on the amount is determined by the temperature change. And they dissolve 124.595, so that would mean you get 1.5 grams of NaOH, and it rises to 21.6 degrees Celsius. The temperature change is 3.6, simple subtraction. So, a student added 10 grams, which is 0.25 moles of NaOH to 40 milliliters of water. He measured the max temperature rise. He adjusted the value of the standard enthalpy change of the solution. Give 2 reasons why he is incorrect.
Good afternoon, staff. One more announcement. The book study meeting is today after school at 2:30 in the
Pardon the interruption.
for any teachers interested in beginning that professional development activity. Today is the last day to begin that activity in the TEL studio at 2:30. Thank you.
So, suggest 2 reasons why he would be incorrect in this experiment. Alright, finding the enthalpy of combustion is very similar to enthalpy of using MCAT. In this case, we're heating water using an alcohol, a hydrocarbon, something that gives off energy, and figure out how much the water rises will determine the enthalpy of combustion of that hydrocarbon organic material. Here would be an example of one. Mass of water in a calorimeter is 100 grams. So here's your mass of water. The finishing of the propanol burnt was 0.21 grams, and the rise in total temperature is 10.7. So from that information, you can find MCAT, find the energy, and you can find per mole of your organic to find how much energy per mole that organic produced. Okay, student calculated the standard enthalpy change of combustion of ethanol to be negative 870 kilojoules per mole. The data book value is negative 13.67 kilojoules per mole. Explain the difference between these two values.